Hi students, welcome to NADAR'S YouTube channel. Students, in this class you are going to learn about meter bridge. Students, the meter bridge is a instrument. It is used to determine the unknown resistance of the resistor. The unknown resistance of the resistor, it can be measured by using meter bridge. Here the meter bridge is another form of Wheatstone bridge. Last class I taught to you about the Wheatstone bridge. The another form of Wheatstone bridge is the meter bridge. Here it consists of a uniform manganese wire AB of 1 meter length. It consists of a manganese wire. It has length is 1 meter. This wire is noted by letter A, B, is stretched along a meter scale on a wooden board between two copper strips C and D. Students, this is a copper strip C, this is a copper strip D. Here this manganese wire has 1 meter length, is stretched along a meter scale, on a wooden board between the two copper strips C and D. See the diagram. Okay, this is a copper strip C, this is a copper strip D. Here the AB is a manganese wire. This manganese wire has a length 1 meter. It is stretched along a meter scale on a wooden board between the copper strips C and D. The another one, copper strips E, is mounted on the wooden board between the strips C and D, copper strips C and D, here with gap G1 and G2. See the diagram. Okay, so this is a copper strips E is placed between the copper strips C and D with the gap G1 and G2. Between these two copper strip, another copper strip is mounted to enclose two gap G1 and G2. A unknown resistance P is connected in G1, okay, which to be measured, that is connected in G1. And a standard resistance Q, it is a known resistance, is connected in gap G2. Now a jockey is connected to the terminal E. The J is a jockey, is connected to the terminal E through a galvanometer and a higher resistance. Okay, so this is a jockey. This jockey is connected to the terminal E through galvanometer. The exact position of the jockey on the wire can be read on the scale. A Lagrange cell and a key K are connected across the end of the bridge wire. Okay, so here one Lagrange cell with the key is connected between the A and B. Okay, the position of the jockey on the wire is adjusted so that the galvanometer shows the zero deflection. Okay, at the initial position, when the jockey is placed on the manganese wire in a galvanometer, it is to show the deflection. Now we adjust the jockey on the manganese wire at a particular position. Here in a galvanometer, it is show the deflection is 0. Let the point be J. We can note that the point be J. The length AJ and JB of the bridge wire, now replace the resistance R and S. Okay, so at a particular time, the galvanometer is show the deflection 0. we can note the part AJ and the part JB are the resistance R and S of the Wheatstone bridge. Already you know that the Wheatstone bridge, it consists of four resistances. Okay, it consists of four resistances P, Q, R, S. It consists of four resistances. In this, the P is a unknown resistance, Q is a known resistance. When the jockey is placed at a particular position on the magnet wire, the AJ is considered as the resistance R, the JB is considered as a resistance S. Okay, students? So we can apply the formula of the Wheatstone bridge, that is P divided by Q is equal to R divided by S. Okay, so here the P divided by Q is equal to R divided by S. What is the values of the R and S? Here the value R means it is equal to the length AJ, and it has a resistance, that is R dash. So we can write that is R dash AJ divided by what is in the S? S means the it has a resistance is R dash, it has a length is JB, where the R dash is a resistance per unit length. We consider the R dash is the resistance per unit length of the wire. So we can write the R dash cancelled from this equation. Both are having the same values. So R dash cancelled, because it is one of the 1 meter long magnet wire. So it has a resistance is also same. That is the same wire. So we neglect this R dash. So we can write P divided by Q is equal to AJ divided by JB. So AJ means that is equal to L1. Already we know that. According to this diagram, we consider the AJ is equal to L1, JB is equal to L2. So we can write P divided by Q is equal to L1 divided by L2. P divided by Q is equal to L1 divided by L2. So if P divided by Q is equal to L1 divided by L2 mean we can write P is equal to Q into L1 divided by L2. To find the specific resistance of the material of the wire in the coil P, the radius R and length L of the wire is measured. Okay, to find the specific resistance. So here the specific resistance or resistivity rho can be calculated using this relation. Already we know that resistance of the wire is calculated by using the formula of resistivity rho into L divided by A. L means that is the length of the wire divided by area means that is a noted by letter A. So by arranging the above equation we get the resistance rho is equal to, the resistivity rho is equal to resistance into A divided by L. Okay, we can modify this formula. The resistivity rho is equal to resistance into A divided by L. If P is the known resistance, the equation become rho is equal to P into A divided by L. Here what is the area of the wire? The area of the wire is a pi r square. Okay, it has a shape that is a circle. So we can write area of the circle, that is a pi r square divided by the length of the wire is L. So the specific resistance of the wire, it can be calculated by using the formula of rho is equal to P pi r square divided by L. Thank you, students.